We're talking about solving polynomial equations, and we're talking about factoring. So we want to think about what should we expect when we come up with our factored form of the polynomial. And so we're talking about our behaviors near to the zeros. And when factoring, and we get our binomial x minus k of a function is raised to an odd power, 1, 3, 5, 7, the graph of f crosses the x-axis at x equals k. And so here we have the polynomial actually crosses the x-axis at x minus 2. And we know that whole binomial is raised to the 1 power up here. If it's not written down, we understand that it's 1. However, when we have a factor of x minus k of a function is raised to an even power, the graph of f touches or is tangent to the x-axis at x equals k. So here we have x plus 1 squared, and so the graph starts going up towards the x-axis. It's tangent at x equals negative 1, but doesn't cross, and then it comes back. So here we have a multiplicity of 2, and here we have a multiplicity of 1. If we look at our graph here, we can see that the graph starts down because it's an odd function, degree 3, because we have two zeros for this first binomial and 1 0 for the second binomial. So that's degree 3. So it comes down. We have a double root here, so it's tangent to but doesn't cross. And then we have a single multiplicity of 1 here at 2 where it actually goes through. And we can see that on our other example, the first example that we did, where we expected 6 roots, and that's what we calculated. So we have a degree 6, and we went through and factored it. Now the exponent on this binomial up here is 1, and the exponent on this binomial up here is also 1. So when we solved it, we got 2 different roots for each one of these binomials. We got a positive and a negative, positive and a negative. However, here our multiplier has our variable is squared. So that's where we're going to expect a multiplicity of 2 at 0. And so when we're looking at our graph here, we see that we have 5 individual solutions, but we have a double root at 0, so it comes down but doesn't, and it's tangent to but doesn't cross the x-axis where everywhere else it crosses the x-axis. And our last example that we did, we solved already. Again, we have a degree 5, so we're expecting 5 zeros, and we calculated 5 separate zeros. Exponent here is 1, exponent on this binomial 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 is also 1. So we expect that our graph is going to cross at each one of those zeros. And when we look at it, we do see that at every point, every zero, it crosses. It's not tangent to for each one of those. So that's because at each one of those zeros, it had an odd exponent.